Welcome back. This is Emmett. In today's video, we will be tackling this problem. The figure below shows an equilateral triangle fractal. If the largest dark gray triangle has a height of 4, what is the total area of the infinite amount of dark gray triangles? So pause the video, try it out, and get back to the video when you're ready. The first thing to notice is that each successive triangle moving away from the center is 1/2 the height of the previous triangle, right? So if this is 4, this has a height of 2, then 1, then 1/2, etc. And these also do, so that would be 2, 1, etc. And so what we can do is somehow use this in combination with an infinite sum to get the area of all of the dark gray triangles. Now the way I'm going to solve this is I'm going to focus on these triangles up here, because what we can do is find the sum of all of these dark gray triangles and then multiply it by 3 because these have the same area, and then finally add the middle triangle at the very end. But first we need to find the formula for an equilateral triangle area given height. So using a 30, 60, 90 triangle that I'm going to draw here, we know that if this is the hypotenuse, the height is √3/2 times hypotenuse. However, we are given the height and we don't know the hypotenuse, which we need to solve for the area because that will be the base. So what we can do is we can say height equals √3/2 times hypotenuse, and then solving for hypotenuse, we get hypotenuse equals 2√3/3 times height. And now this is the hypotenuse is also the base of an equilateral triangle. And so we are going to write out the formula for the area of a triangle is 1/2 base times height, right? And now we have the base is what we just found. So we'll write 1/2 2√3/3 times, I'm going to let height equal h, times h, right? And so we get that the area is √3/3 h squared. And this formula right here can be used with an infinite sum to find the area of all these triangles. Alright, so let's write out the first few terms of this infinite series. So the first height is going to be 2, and the next height is going to be half of that, which is 1, and then we have 1/2, etc. And so notice how there's always going to be this constant, and there's always going to be this quantity here squared. And this quantity goes 2 to 1 to 1/2 to 1/4, etc. So it's always going to be 1/2 to some power. So we can use this to write an infinite series. And so it's going to be an infinite amount of terms because there are an infinite amount of triangles. And then we don't know the starting term yet, but we know that there's a constant, and then there's always going to be 1/2 to the n, and this is going to be squared. And so see how if this is the first term here, and this is going to be 2, we need 1/2 to the n to equal 2. And so 1/2 to the -1 equals 2. So the starting term is going to be -1, or the starting n is going to be -1. And so now we have this infinite series, and we can find the sum of it to find the sum of the area of all these infinite triangles up here. So I'm going to rewrite this first by putting the constant out front, and then we have n equals -1 to infinity, and then I'm going to rewrite this as 1/2 to the 2n, which can be also written as 1/4 to the n. And so now we can find the sum of this infinite series and multiply it by √3/3. So using the formula for the sum of an infinite series, we have a over 1 minus r, and a is the first term, which is going to be 4, and then r is going to be 1/4, the common ratio. So 1 minus 1/4, and that's going to give us 4/3/4, which equals 16/3. And so taking root 3/3 and multiplying it by 16/3, we get 16√3/9. So this right here is the total area of all of these infinite triangles up here. Alright, so because these triangles here and here have the same combined area as this set of triangles here, we can multiply 16√3/9 by 3. And that gives us 16√3/3. And so finally, now we just need to add this with the area of the middle triangle. And so the middle triangle is going to be √3/3 times 4 squared, which is going to be 16√3/3, which is pretty interesting. It's the same value. And so 16√3/3 plus 16√3/3 equals 32√3/3. And so that's the answer. I think this problem created a nice visual and was also a nice application of infinite series. As always, I hope you learned something and have a nice day.